Okay, we're on day 2 of Maxima and Minima, and we're going to do a quick review of what completing the square is. Now, you've done some of the homework already for this, or the seat work for this, and you've seen some examples, but we're going to review it just to make sure we know why we're using complete the square. So this allows you to express standard form in vertex form. So ax squared plus bx plus c is standard form, and we can use completing the square to express that same quadratic equation in vertex form. That allows us to much more easily understand what the problem may look like, what the vertex is, etc. Now, please take a moment to pause the video and copy that so that you have it in your notes. And in terms of outlining the algorithm, this is in language that makes sense to me, but it's more important for you to review this and then write this in words that you will understand. Ultimately, the best practice for completing the square, or the best way of understanding it, is by rote practice. So completing many questions that have you completing the square in order to express standard form in vertex form. Once you've done it, let's say 5 to 10 times, you should have mastered it by then. But there are a few things you need to look out for, which we're going to look at in number 3 in a moment. So let's take a look at first at number 2. So the algorithm, or the pattern or process that we follow, set of rules that we follow for completing the square, is group the first two terms together. So for example, I'm going to use this example right here. So for example, we would group x squared plus 8x together. Factor out a numerical coefficient if possible. Now in this case, we don't have a numerical coefficient. You know what though? Let's use this one then. Let's make life a little easier. So in this case, if we had to factor out a numerical coefficient, we take a 2 out, and we write x squared plus 6x plus 11. That's what it tells you. So factor out a numerical coefficient if possible. Have b. So in this case, our b is now 6. Half of b is 3. So we're going to write x squared plus 6x, and it says square this value. Well, 3 squared, half of b, and half of 6 in this case, is 3. Squared is 9. Then it says add it and subtract it within the brackets. So plus 9 minus 9. And you still have your plus 11 outside. So add it and subtract it within the brackets after the first two terms. So after these two, you add it and subtract it. Take the square being subtracted outside the brackets. So that's saying that you really want to get rid of this negative 9. How do we take it outside? Well, it says here, be sure to multiply it by the factored out numerical coefficient. We have to remember, because it's in brackets, we're multiplying the 2 times the negative 9 first, because 2 is being multiplied by everything in brackets, or what's in brackets is being multiplied by 2. So when we kick it out or get rid of it, it's going to become a negative 18 plus 11 outside the brackets. And inside you'll have x squared plus 6x plus 9, which is a perfect square trinomial. And we factor the perfect square trinomial, and we would get 2x plus 3 squared, and negative 18 plus 11 would be negative 7. This is the example you saw in last day's handout. And then we simplified, so then we're done. Okay? If you want to record that, you want to pause the video, because I'm going to erase it here. Oops, that's not what I want to do. Let's just do this. That will probably go a little more slowly, but it'll work nevertheless. Okay, so let's get the eraser. And this is gone. Okay. Now we want to complete the square. Sorry, we want to look at number 3. Give an example of an equation that is easy to CTS. Well, this is easy because the numerical coefficient, or the a value here, is 1. And so the other thing that's easy is also that we have 8 for our b value. And the reason why that's easy is because it's an even number. And so when we cut it in half, we don't end up with a fraction. We have 4. 8 divided by 2 is 4. So eventually you're going to have x squared plus 8x, and 4 squared, let me fix that. 4 squared is 16, so plus 16, minus 16, etc. And so that becomes a little bit easier. Where, just to erase this properly. Okay, where it becomes a little more difficult is here in the example I just showed you. We're grouping the first two terms, and now you have to take out a numerical coefficient. Not a big deal. if you look at this as much harder, and this is harder because once we take out the 2, we end up with 2x squared plus 7x plus 3. And we're not taking out an x. You may be wondering again, I taught this last day, but you may be wondering why we're not taking out the x as well here. And the reason you're not taking the x out is because you want to create a perfect square trinomial. So we want the first term to be x squared because it's a perfect square. What's difficult about this one is that when we cut 7 in half, it's 7 divided by 2. And that's what we're going to square, which will equal 49, which would equal 49 over 4. And then we're going to add that and subtract that. And this is where it becomes a little more confusing because some of you don't like to work with, I know some of you don't like to work with fractions, but that's what we're going to be working with. Okay, and we're going to get into that today. And much harder would be working with something like this. And we're going to factor out, now we have a negative. So you just have to be careful when you're taking out a negative 3. That negative 3 times a positive x squared and negative 3 times a positive 3x and then minus 17. And what's still difficult is that you have a negative number, an odd number here. So we're going to have 3 over 2 as half of b because we're cutting it in half. And so that makes life a little bit difficult. So let's not worry about the difficulty. Let's just master the concept. So let's take a look here. Let's take a look at example A. You'll notice that I erased what you have in your handout, and I may have rearranged these questions on you. So take a look at the question and make sure that you are working on the same one. I rearranged it because I think this is a little bit easier. So first thing we want to do is remove the negative because we don't want the a value to be negative. So take out a negative 1 times x squared. Negative 1 times a negative 10x would be positive 10x. And a negative 1 times a positive 12 would give me a negative 12. So you just want to make sure that we're accurately representing this. So if you take a look at here, if I show you the negative 1 and we distribute negative 1 times x squared would be negative x squared. Negative 1 times negative 10 would be positive 10x. Negative 1 times positive 12 would be negative 12. So this is accurately representing what we had in the first step or in the original question. I'm going to erase the 1 though because we don't need that there. All right, and I will take out these arrows as well just for some clarity. Okay, now we are going to group our first two terms. So we're going to have x squared minus 10x, and we'll leave the plus 12 on its own. Okay. Actually, you know what? I made a mistake. I sincerely apologize. We don't want to take this. We don't want to change. We are supposed to leave that alone. That stays as negative 12. I apologize. We leave the third term alone. Remember, we're only grouping the first two terms. So I only want to take the negative 1 times x squared, and negative 1 times negative 10x. The third term we're leaving alone. I apologize. Okay, so now we have negative x squared minus 10x, and then we're leaving the minus 12 alone. We do not need to worry about the third term. In fact, part of our algorithm up here, we can write here as a first step, leave the third term, or the c, alone. So, or you can say ignore it. Ignore c in this case. Okay? So we only group the first two terms together. Then we have y equal negative x squared. Half of 10 is 5. So we're going to write negative 10x, and half of 10, negative 10 is negative 5. Squared would be 25. And then minus 25, close the bracket, and the minus 12, or the c value, stays there. Y equal, and now we want to get rid of this negative 25, but beware that we technically have an imaginary negative 1 here, and we have to multiply that first before we boot it out. Okay, so we have negative, close the bracket, x squared minus 10x plus 25, close the bracket, and now we're booting out the 20. We're multiplying negative 1 times negative 25, which would be positive 25 minus 12. And if you like, some of you like to keep that in order, so you could write the negative 12 was there all along, and then write plus 25. That might be a little easier for you. Now we're going to simplify this right here, which is our perfect square trinomial. we did all this so that we can get a perfect square trinomial, because when factored, this looks like this. And the reason why it's subtract or minus 5 here is because we need the sum total to be negative 10x, and also needs to multiply to positive 25. And so negative 5 times negative 5 is positive 25, but a negative 5x plus a negative 5x is negative 10x. And negative 12 plus 25 is what we're looking at here, and we're left with a positive 13. And so we know the vertex is 5, 13. We also know the parabola opens downward. That's pretty obvious because there's a negative a value. It has not been stretched or compressed because it is a negative 1, right? All right, let's take a look at this one. Again, group the first two terms. I don't want to make the same mistake I made before. And this time we have a numerical coefficient. So y equal, we're taking out a 2. And so we end up with x squared plus 5x minus 12. So we'll take a look at this for 1 second. Yeah, okay. So now we have a 5 as our term here. And that's going to give us a little bit of grief for those of you that don't like working with fractions. So let's take a look at this now. We have x squared. Half of 5 is 2.5. Or in this case, we're going to write what we're thinking of. I'll write over here. You really have 5 over 2. That's half of 5. And we're supposed to take half, as our algorithm tells us, square it, and then add it and subtract it. Well, what is that squared? Well, this is really 5 over 2 times 5 over 2, which is equal to 5 times 5 is 25, and 2 times 2 is 4. So this is the square of 5 over 2 squared. So now we're adding 25 over 4, and we're subtracting 25 over 4. Okay, again, half of 5 is 5 over 2, and then we square that, add it, subtract it, and continue the same algorithm, just dealing with a fraction this time. Let's work through this here. So now we have x squared plus 5x plus 25 over 4. And you may want to pause the video, see if you can handle this on your own, and see if you got the right answer in a moment. And now I want to boot out this negative 25 over 4. But remember, it's being multiplied by 2. Okay, so I'm going to write negative 12 here. That's continuing my question. And I want to multiply negative 25 over 4 by 2 first. Well, what is negative 25 over 4? Let me do this. Let's erase that and do it. You know what? We could do it up here because we've got room. Negative 25 over 4 times 2, or 2 over 1, really. Remember, you can cross-reduce. If I want to do the long way, negative 25 times 2 would be negative 50, and then 4 times 1 is 4, and then we could divide that by 2 again, and we'll end up with negative 25 over 2. But what you could do right from the get-go, if you recall, cross-reducing, 2 divided by 2 is 1, 4 divided by 2 is 2, and then you'd be done. So negative 25 over 2, whichever way works for you. So we have negative 12, and now we have a negative 25, or minus 25 over 2. Now we continue with our question. Y equal 2 bracket, and now we want to have a perfect square trinomial factored here. We have x, we have a positive and positive, so we know we're going to have addition here, and we have to square root 25 over 4. The square root of 25 over 4, the square root of 25 is 5, the square root of 4 is 2. And here outside we have a negative. We're going to come up with a common denominator, so we need to change negative 12 to negative 24 over 2. So all we've done here, please keep in mind, all we've done is we've changed the, let me highlight this, it might be easier. We have changed the negative 12 to negative 24 over 2. That's what's changed here. y equal to bracket x plus 5 over 2 squared, and negative 24 minus 25 over 2 is negative 49 over 2, and that is our answer. So our vertex is negative 5 over 2, negative 49 over 2. A little more complicated. Let's try another one. I would strongly urge you to try this one on your own completely before following my steps. I'll try and go a little more quickly though, so that you can pause the video and then just watch step by step. So we are first going to group the first two terms, and we're going to take out a negative 2 this time. Negative 2 times x squared, and be careful, negative 2 times negative 10x will equal positive 10x. And then we ignore the third term. Y equal negative 2, half of negative 10 is negative 5, and negative 5 divided by, oh, I made a mistake here. Oh dear. So negative 2 times, let's see here, that's not right, it should be 5. Negative 2 times x squared is negative 2x squared, and negative 2 times negative 5x is positive 10x, and then minus 12, sorry. Y equal negative 2 times x squared minus 5x, and again, half of negative 5 would be negative 5 over 2. We have to square it, which would be 25 over 4, because negative 5 over 2 times negative 5 over 2 is positive 25 over 4. Either way, we're going to be adding it and subtracting it. So now we have plus 25 over 4 minus 25 over 4, and then minus 12. Y equal negative 2 bracket, and then we have x squared minus 5x plus 25 over 4. That's our perfect square trinomial, and now we want to remove this third term by multiplying negative 2 times negative 25 over 4. And again, I'll show you that over here, negative 25 over 4, this time being multiplied by a negative 2, or negative 2 over 1. And again, you can cross reduce. Negative 2 divided by negative 2 would be negative 1. Sorry, would be positive 1. Take that out. Negative 2 divided by negative 2 is 1. And 4 divided by negative 2 is negative 2. And negative 25 divided by negative 2 is positive 25 over positive 2. So what we're going to have here is our negative 12 and then plus 25 over 2. Now we write y equal negative 2. We're going to simplify this so we know that's x. In this case, we need to have negative 5 over 2 because that's the square root of 25 over 4 squared. And negative 12 needs to have a common, we have to get a common denominator here, which will be 2. So we have negative 24 over 2 plus 25 over 2. Y equal negative 2, x minus 5 over 2 squared. Let's fix that. And negative 24 plus 25 is positive 1/2. That's your answer. And so our vertex is 5 over 2 and 1/2. Right. Hope that makes sense, and we'll see you in class.